Hey, what's up guys? My name is the Cherno. Welcome back to the first episode of another little series that I'm just starting here right now, which is going to be called Code Review. Now, as you can probably guess from the title, what Code Review is going to be all about is me taking a look at some of your code and then just giving my thoughts on it. Now, quick disclaimer, I'm not some kind of programming god to be able to just objectively tell you that your code is wrong or right. This is completely going to be just my thoughts, looking at your code, trying to help you out, giving suggestions that are hopefully going to be helpful to you and the rest of the community. That's all that this is about. Don't take this as some kind of absolute guide or anything, but hopefully it's going to both help the community and show some common mistakes maybe, or things that just shouldn't really be done, but then also just be a general good time for us to hang out and look at some code together. So if you're new to the series, which of course you are, because this is the first episode, you can email me at chernoreview@gmail.com. The email address will be in the description below. Basically just attach your code or some kind of link to your code, as well as a description of what your code is, what kind of stuff maybe that you struggle with or that you want me to specifically review, and then I'll download it, set it up. I'll just pick someone arbitrarily and we'll go with that. Also, feel free to mention whether or not you want me to actually say your name on video. Maybe you don't, and that's totally fine. Just let me know. So today we're going to be looking at this gentleman's code. He has written a small 2D game engine with no graphical editor. It can render quads, render textured quads, render text, play music, handle basic stuff, move the quads, a bit more. Still learning OpenGL and C++, how to run. There's some instructions here, as well as a very dodgy looking .rar file, but I'm willing to take that risk for you guys. Also, he's 13 years old. Let's just take a moment to appreciate that. I started programming when I was 16. This person here claims that they're 13. So whatever this code is going to be and whatever I'm going to say about it, it's gonna be just, I'm trying to be helpful. Absolutely no disrespect, absolutely not going to be making fun of this person's code. So let's extract this RAR file and dive into it. But first, this video is sponsored by Skillshare. For those of you who don't know what Skillshare is an amazing online learning community where millions of creative and curious people from all around the world can come together to learn a new skill. Whether you're interested in creative topics such as photography, videography, illustration, that kind of stuff, or you're looking for some help with your business, maybe with marketing or productivity, Skillshare has got you covered. They've really got like this huge library of very high quality courses that all have lessons around 5 to 10 minutes each. They're really bite-sized and they're really easy to just sit down, do a couple in your spare time, and then continue going about your day. And that's one of my favorite things about Skillshare. Now, coming in at just under $10 a month for an annual subscription, I think it's a really great price for all of the skills that you will be learning. But of course, you can get a free trial for a limited amount of time by clicking my link in the description below. So definitely check it out. A really good place to put some of the free time that you may have is into being productive and learning new skills for sure. Thank you again to Skillshare for sponsoring this video. Okay, so let's take a look at this 2D game engine. So the person here has specified that we need to go into the scripts and then the run debug bash file. Let's just take a look at what it actually is first. We have basically echo off, clear screen here, prompt, blah, 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 title, echo starting, building. Okay, so we're compiling using G++. Here in goes a bunch of C++ code as well as a bunch of libraries to link. This seems to be divided up into various different directories, and the output files here are the intermediate files that G++ will actually generate, as well as this final kind of linking stage where we actually link all of these object files here with the library files and all of that and produce an executable called sandbox.exe. Now, I think I forgot to mention that I've never looked at any of this code before or this project structure before whatsoever. This is my fresh eyes on this. So obviously I might be reading things slightly wrong, or just keep that in mind. And then there's echo running, blah, blah, blah. Okay, cool. So I already have a few things to say about this. This is very unsustainable, right? As your engine grows and you have more and more files, you have to manually keep adding them here. Now, you can use G++ in slightly a better way to like just include all of the CPP files and H files and all of that stuff and just make things generally easier. But in general, just having a little batch file that has all of your files that you're trying to compile and all of that, it's cool that you're starting that way, because I think a lot of people do start that way, and well, I think that it's arguably better than starting with like a full-on IDE and having all of that manage that for you. But my recommendation would be for sure to use something like Premake or CMake to just, you know, be able to generate project files for you so that you can easily run this inside Visual Studio and not have to manage the whole build system yourself in like a text file, because this stuff is definitely going to get harder to maintain as the project grows. Anyway, let's try and run this. So apparently we should be able to just open up command prompt and then just run scripts slash, I think, run debug.bat. Now this doesn't work because, well, I don't have G++ installed. So let's go ahead and open a min-gw terminal here, and hopefully if I navigate to this directory, and then I will run scripts slash run debug.bat, we should be okay. Okay, so check this out. We have some pretty interesting music going on, and I think we can even kind of move this around a little bit. Looks a little bit kind of, well, not very smooth here, but 60 FPS here. We've got some text going on. Looks pretty cool. I even like the attention to detail here. We have an icon and all this stuff. Oh, frame rate seems to have dropped a little bit. No, we're okay. Pretty cool. So we can render quads and can't resize the screen or anything like that, but that is basically what the project looks like. So now let's dive into the thing that matters, the code. So just a few more thoughts regarding the project structure. Now we have an assets file here, a bin file, an include file, a scripts file, and a source file. And of course, when I'm saying file here, I mean folder. With all of this stuff in here. So that's pretty nice. I like to see this kind of layout usually. It's good. One thing I would recommend is maybe, since this is an engine and not just a game project, it would be good to see some kind of separation of projects. So maybe the engine code should be in a single folder, and then the actual game code can be somewhere else. And the game can contain like assets and all of that, whilst the engine code will contain more of the kind of engine code base. So if we were to open this folder in Visual Studio Code over here, we'll just be able to easily browse this repository. It would be nice to see some kind of, setup environment here to be able to run and debug this through VS Code if that's what you've chosen to use and not Visual Studio, but that's obviously okay. Now I'm apparently in this file here. Let's go and I guess we'll start at the top. So far the source directory is fairly standard. I like to see this vendor folder. Again, this looks a little bit similar to the design that I'm using for Hazel, which is fantastic because it's cool to see this kind of structure, with like a vendor folder with all the third-party stuff coming from someone who's 13. Like, that's really cool to see. So I'm glad to see that hopefully what I'm doing here on YouTube is also helping out people with this, because this looks pretty good. I would never have guessed this was someone who was 13. My code at that age was, well, non-existent, but my code in my first couple of years of programming was nowhere near this organized. So that's already really, really cool. Okay, so we've got Sandbox, we've got tools. Again, this stuff to me, like Sandbox obviously seems like it should be in a separate project. Now this person doesn't really have projects. They are just compiling everything with G++, which is fine. They could still compile this into like a, the engine code into like a library file, into a static library file, then link it to an exe file and all of that stuff. But, we're not going to get into that. That's not that important, especially not at this stage in their programming career. Okay, so basically I guess the main function is over here. Let me just make this slightly bigger. We start by just playing the music, which is cool. Then we also set the icon on Display Manager. Now I'm noticing that these kind of variables here, these instances of classes, I presume, are coming out of nowhere, right? Like, they're obviously global, and you can see them up here actually in this sandbox.cpp file. They're not even like static global, meaning they're confined to this translation unit, to the CPP file. They're actually just full on global. Not a great design. In this case, honestly, like, it doesn't really matter too much, but what I would have liked to have seen is this display manager. There's probably no reason for it to actually be global. Like, it's not even used in this kind of stuff. This is also slightly dodgy. What I probably would do is just cut this code out and just put it over here into main. This is already a lot better because, for one, you'll be calling the destructor as you exit over here and not sometime in static destruction, but also this stuff is just kind of bound to the scope and it won't leak out into the rest of your entire project in that kind of global space. But yeah, everything else is okay. Setting up some icon stuff, setting resizable. Yeah, this looks pretty standard to me. We've got this kind of while loop here, which is the game loop here, or the application loop. Looks pretty fine. I would just say that this kind of stuff definitely shouldn't be in your main file. I would make an application class and have maybe a function called run, which contains this actual game loop. More of like an organizational thing, not really going to impact the like performance or the general like way this application runs, but it's something that's very useful to do just to keep your code more organized. So display manager is pretty much the first thing that gets created. Let's take a look at the display manager class. I'm going to try and be fairly brief here just because obviously this is quite large and I could definitely sit here forever, but I'm going to try and be kind of brief. So we have We have the display manager class, which takes in a width and height and a title. So immediately looking at this, I would give a couple of suggestions. First of all, try not to use unsigned int. It's a little bit outdated. Use something like uint32t. What this is it's kind of a more modern, we'll say, unsigned int type. The big thing that it actually has is a size. You know, there's never a dispute about how big this integer is. We know that it's an unsigned int is fairly arbitrary. We don't know what the size is. 32 bits is actually written here. We know this is a 4-bit unsigned integer. As an added bonus, it's less characters than unsigned int, so it would actually make everything else look a little bit cleaner. So I always try and use uint32_t for my unsigned int types. Now, std string title. With this, no point taking it in by value like this. Put a little const reference here, because if you don't, what you're doing is actually copying the entire string into the display manager constructor. This is bad. I mean, it doesn't necessarily have to be bad depending on the size of your title string and all of that. But essentially, by changing this to a const reference, you're doing one less copy potentially. I mean, you'll still need to copy it eventually into win title, but you're not copying it first into the constructor and then again into win title. Copying strings is not that great, because every time you copy a string, the new string has to heap allocate memory for it to be able to be stored. And again, this is subject to like things like small string optimization, but for the most part, we want to avoid that. Pretty much anytime you take in a string or any class that is like larger than, let's just say 8 bytes, for the most case, you want to just make it a const reference. Unsigned int, as I said, to uint32t. Everything else looks pretty good. Now, personally, this is a very minor thing, but personally, I like to actually store this kind of private stuff at the bottom of the file. Now, the reason I like doing this, and I actually used to do it the other way around, but the reason I like doing it like this is because when someone is looking at this header file, for the most case, right, usually they want to be able to see what they can do with this class, right? They don't really care about the implementation details, which is like, all of this stuff. I don't care that it has some private functions that I'm not even going to be able to call, right? For the most case, for the most frequent case, I should say, in most cases, and that's the right phrase I was looking for, they just want to see what is up and what they can do with this class. And by putting the public stuff first, you're just kind of keeping everything a bit more organized and making it so that you can actually have that stuff here. We have this Usenvidia H little file here. Basically what this does is tries to force dedicated graphics if you're on a laptop that has integrated graphics. This is fine, I guess. This is a little bit of a consequence of using OpenGL for rendering and not something like Vulkan, which actually lets you programmatically pick what physical GPU you want to use, and that way you'd usually pick something dedicated instead of like an integrated card for something like a game engine. So that's what this is doing. That's totally fine. It's in a header file, which I assume gets included into some kind of translation unit later on. Text shader, just stumbled upon this file accidentally. This is like my first thought on looking at this is, why is everything in the header file? This stuff should be implemented in a CPP file. As you're developing this file, any kind of change to this code is going to force everything to be recompiled. That includes this header file. It's a lot better to have that in a CPP file. This stuff seems pretty good. I tend to not really use exceptions, just as a stylistic thing in most of my code, but it's totally fine to use them in most cases. Yeah, just creating OpenGL shader stuff. I probably separate this stuff into like a CPP file, as I mentioned. But everything else I think looks pretty good. Pretty standard uniform setting going on here. Check compile errors for our shader. That looks pretty good as well. Text rendering stuff. Yeah, this stuff seems pretty good. Again, whenever I see SCD map, I tend to usually use an unordered map. The reason is an unordered map is a hash map. It just tends to, in most cases, be faster than a map for looking up things, but it definitely depends on the size and certain other things. So I'm not gonna just, blindly give that advice, but I usually use unordered map. And I think that for the most part, that should be the first thing you choose. Okay, sound manager stuff, renderer stuff. Okay, this is interesting. So we have a vector of float pointer, which are our vertices. Okay, let's take a look at renderer.cpp because I'm really interested to see why we have a vector of pointers. So it looks like we have, in the renderer add, we can add a quad. I don't know what a quad is. It'd be nice to, let's just, what's the right? I think that's it. Quads. Okay, so what this is we're creating a bunch of vertices here on the stack and indices. Then we're copying them onto the GPU here as an array buffer and an element array buffer. So we have our vertex buffer and our index buffer. And that seems like that's all we do here. This GL call macro, which I'm assuming, I'm not sure if I can go to it, not really. I'm assuming this GL call thing, let's just try and search for it. Here it is, debugger. Yeah, so this is kind of like an old way of checking errors in OpenGL. You don't really need to do anything like this anymore. If I open up Hazel and I try and just go to be honest, I don't even know where this is, probably in like GL context, maybe? I have no idea where my own code is. I think OpenGL render API. You can see we've actually got a callback for error messages now. So GL debug message callback is something you can use as of like OpenGL maybe 4.3, just off the top of my head. And if you enable GL debug output and GL debug output synchronous, then you don't actually have to wrap every GL call in that kind of GL error check, because anytime you get an error, it will just simply call this callback, and you can even put a breakpoint in here and see whenever it's called, and then use that. As long as you've got synchronous enabled, so it's not asynchronous, you'll be able to look at the call stack and see exactly where it's coming from. So basically gives you the same features as what this does, except, with the assertion for the breakpoint and all that stuff, but without having to wrap everything in this macro. So it just makes life a little bit easier, and I would recommend that you use something like that. Okay, so we take in a quad, we push it back, and then what we do here, this is very interesting. So into the M vertices vector, we're actually getting the vertices from the quad. So let me first of all see what that's even doing. So where are the vertices from here? Am I misunderstanding something? So quad.vertices. Vertices. I can't see vertices. So that's a bit odd. Quad.vertices. Where is this thing? Anyway, it looks like, it's not here. I've actually found another quad class here, so maybe this is what it is. But anyway, this is a vector of vertices here. And I guess this is what's being pushed back into here. Now, this is already very dodgy. I'm not even sure how this is working exactly, because this is a temporary object, right? So what we're doing here is we're copying a quad over here, which first of all isn't ideal because the quad contains a vector. And so we're actually copying all of this data every time we enter this function, which means that, well, that's not great for performance, because vectors, for example, will dynamically allocate memory in most cases, as will potentially other stuff here. So it's a pretty heavy copy, but on top of that, this object is obviously temporary. It's going to cease to exist at the end of this function, and yet we're actually getting the pointer to this vertices vector contained within this quad instance that later gets destroyed, and putting it into our member function. So in other words, after this function, mVertices is going to contain a float pointer to memory that's been deleted. So that's already like a bug. This stuff, okay. So this shouldn't really work either, I'm fairly sure, because at, I think, returns a constant reference, potentially, which means that how are we assigning to a constant reference? Not sure how that compiled, unless I'm just looking at the wrong thing. Yeah, but this stuff definitely shouldn't be happening. If you want to actually push indices back, you should allocate your own memory and copy that instead of relying on this pointer, because that memory is likely to get deleted. Yeah, that's very likely to cause a bug if it even works now, which I doubt it. Okay, GL call, this stuff, again, GL call can get removed. Everything else is probably okay. This is just preparing some OpenGL stuff for rendering, which is totally fine. And then we have the actual render function, which just enables the shader here, sets the view matrix, calculates the model view projection matrix, binds the vertex array, and then does the draw call. Now, this, again, not being called at the moment, so I assume half of this is broken. Maybe this is why, but this doesn't do anything, but we would be setting the uniform here into the shader. Okay, so that's the renderer. Seems pretty fine, I think, to me. Let's try and go back to our files here. What else should we look at? I'm trying to just figure out what even to look at, because obviously we could be here for hours. Okay, the text renderer itself. So this is interesting. We're drawing a string here. Again, try and use const references for this kind of stuff. Then we're doing a const iterator here. We're iterating through all the characters. I did see free type being used earlier, which is great. So we're actually able to, when we initialize the text renderer, it's going to fetch certain characters, I assume, from the Arial font here. And then we can actually use OpenGL here. And in this case, we're actually going through 128 different characters and then retrieving them from free type, the actual pixel data, and then storing them using OpenGL into a texture, essentially. Now, this, again, is going to create 128 different textures. It's a lot better to use something called a texture atlas or a sprite sheet to just store all of these characters in one texture. So instead of having to generate 128 different textures and then having to rebind them all the time, you just have one kind of sprite sheet which contains all of the characters that you need right there. Now, obviously, that's something a little bit more advanced and a little bit harder to set up, especially for someone who's 13, let's be real, but definitely something that I would do, because having 128 different textures for all of your characters aren't great. Also, you are going through all of the characters here, right? So C is being used here. We're literally going through all of the characters that this font contains almost. So that's also not really necessary. What you can do is just do this on the fly. So whenever you are going through text that requires a certain character, you can check to see if that character exists. And if it doesn't exist yet, because it's the first time you've used like the letter A, at that point in time, you can actually retrieve it from free type instead of having to create 128 different textures up front without even potentially needing half of them. So that's also something I would do. But other than that, this is pretty standard, just creating a quad basically, so that we can actually, with all the font metrics and all of that, so that we can actually draw each character here as a quad, and then just drawing it over here. Pretty standard. And then advancing X so that we can draw sentences and stuff like that. Pretty standard text rendering using free type. Cool, that's really impressive. I remember one of the, when I did text rendering for the first time, it probably took me a month, if not more, to figure it out. And I was 20, I think, ish. So text rendering definitely isn't that easy, and it's definitely the most impressive thing in this engine. Rendering quads is not that hard, I think. Again, it's hard for me to picture what it's like for a 13-year-old, but I would think that that's kind of not too difficult, but I'm definitely impressed by all of this text rendering stuff. This looks really good. And to be honest, looking through this code, sure, there's some stuff here that probably belongs in the engine state and the renderer, not necessarily the text renderer specifically. And, there's this, creating 120 different textures, not great either. But, for the most part, it definitely very tidy code, very impressive. And I honestly, this code, I would not be surprised to see this kind of code laid out in this way, from someone on my team at EA or something like that, back when I used to work there. And that's not to say that EA code is bad. It's just that this person's code is pretty good. Okay, there's some brief physics stuff here, which, it's just a vector2 class. And I think textured quad is also something really interesting. Now, one thing I do want to mention is that one thing I've noticed here is that the quads that we're creating here, they're basically different every time. So we create a quad with an X, Y, width, and height, right? Which is what's going on over here. And then every time we need a quad at a different position, we create a new quad and we create a new vertex buffer and, set up all the attributes and do all of that stuff. And this is a textured quad, so we also, do all of this stuff for it. You don't really need to do this. What you can do instead is basically what we do inside Hazel. And if we look at the 2D renderer, we just have a quad that we create once. That's what's happening here. We have a bunch of quad indices. Actually, this is for the batch renderer. But what we do is we basically create a single quad that is a 1x1 unit quad. And then with that quad in mind, we upload it to the GPU and create a vertex buffer out of it as usual. But then if we want to render a different sized quad at a different position, and if let's say we weren't using a batch renderer, we could just simply use a transformation matrix, so a scale, rotation, translation matrix, to just manipulate this one quad. So you can draw the same quad many times, but then set a uniform mat4 to be a different transform matrix. And that way you can get any kind of quad you want with just these vertices. And you can create them once, and you never ever have to create another quad vertex buffer again, ever. So it's really, really useful. And that's basically how I would probably write a little quad renderer if I was not trying to batch them all together or do anything like that. So definitely something to consider, because you don't really need to have a textured quad class. You can just have a function inside your renderer called like submit quad, kind of like what you're doing here with the add function. But then what that can do is just simply create a matrix based out of what the translation, rotation, and scale that the person wants the quad to be rendered at, or the callee, I should say, wants the quad to be rendered at on your screen. And then that's really all you need to do. Then you can just do a draw call, or push it back into some kind of queue here, or a list with that matrix, and then do a draw call with that matrix being set as a uniform, and that's kind of it. Hopefully that makes sense. Everything else, I think that's about it. I think we've gone through pretty much everything. I would definitely clean up that second quad file. I don't know why I found two. Looks like there's one in source. No, that is a CPP file. I'm really curious why I found two different ones. That's kind of weird, isn't it? Because I definitely didn't open this project twice. Not sure. Anyway, hopefully you guys enjoyed this little code review. As I mean, there's no huge problems here. From the code that I've been looking at, this could easily be like a 20-year-old, 25-year-old university student's code. Like, this is great, and if you really are 13, then amazing work, and if you really did write it yourself, then I'm definitely very impressed. I think you've got a lot of potential, obviously, and just some minor C++ issues like passing things by const reference and using uint32t instead of unsigned int, and just some standard stuff that I see all the time as well, with maybe not really quite understanding how pointers work, and how if you really want to take ownership of memory, you may have to copy it, and all of that stuff, like what we saw with the whole vector of float pointers, and then just simply setting that to be the data of some other quads vector that may be deleted later on. That, apart from that kind of stuff, yeah, looks absolutely great. Particularly impressed with the whole text rendering situation. That's really cool. And if you figured that kind of stuff out on your own as well, then like absolutely well done. If you have some code that you want me to look at, then check the email address in the description below. It's chernoreview@gmail.com, and I'm looking forward to reviewing a lot more code in the future. Let me know what you thought. This is the first episode. If you just don't like the format of it, or if you did like the format of it, or if you want me to focus on some other stuff, definitely leave a comment below. I'm trying to get as much feedback as possible since we've just started this series, and I hope that it will be something that we can enjoy doing a lot more of in the future. Don't forget to hit the like button if you did enjoy this video, and don't forget to check out Skillshare using the link in the description below. Thank you all for watching. I will see you later. Goodbye.